Hello everyone, welcome to today's video. Today's video will be discussing about a case study on logistic regression. We'll be using HR analytics to do this particular case study and I will be showing you all the practical implementation of logistic regression using HR analytics on SaaS. Now the agenda of our today's video is first I'm going to introduce to you all the case study that we are going to work upon for logistic regression, our primary goals, the concept of multiple logistic regression, and then we'll move to the portion of practical implementation. So let's discuss about the case study. Let me introduce to you all the case study. The case study that we are going to work upon is we are going to measure the employee attrition, that is the departure of employees from an organization necessitating the replacements, which is going to help us to improve the overall company performance, the team dynamics. This will also influence productivity of the company. Now the different factors that influence attrition are like business travel, daily rate, hourly rate, marital status, monthly income, job involvement, job level, monthly rate, number of companies worked, years at company, years in current role, years since last promotion, years with current manager, and etc. Now, what is the importance of this particular project that we are going to work upon? We are going to basically measure the probability of employee retention, that is whether the employee will stay in the company or not. If the employee retains in the company, that is going to be even, that is probability of y equal to 1, and if the employee leaves the company, then that will be probability y equals to 0. So we are going to build the predictive model or logistic regression model to calculate the probability of employee retention. So number of statistical methods will be used to build this particular model, and based on that we are going to take the decision for workforce planning, talent management, and the resource allocation of our company. So the conclusion that will be drawn is we are going to draw the conclusion, or we are going to predict the probability of employee retention in the company. And based on that, the company is going to take strategies. Now, the primary goal of our project is understanding employee attrition and retention probability. So now let's come to the objective. Employee attrition, often referred to as employee turnover, is the process of employees leaving an organization and needing to be replaced by new employees. Attrition occurs when employees voluntarily leave their jobs, retire, or are terminated. It is a common concern for business and organizations because it can impact productivity, team dynamics, and overall company performance. Attrition rate is influenced by various factors such as business travel, daily rate, hourly rate, marital status, monthly income, etc. A company is measuring the attrition rate of employees, that is whether the employee will retain in the company or not. Now our objective will be first we'll understand the concept of logistic regression, and then we'll be predicting the value of our dependent variable, which is taking binary outcome, which is a binary variable, taking the value 0 or 1 using the different independent variables or predictor variables. Now the key terminologies that we are going to come across are, first is the dependent variable. Dependent variable is the variable that we are going to predict, which is a binary variable having binary outcomes, which can take value 0 or 1. Independent variables are the predictor variables which are influencing the dependent variable or the outcome variable. Independent variables can be continuous in nature as well as categorical in nature. And at last we are going to build the logistic regression model, which is going to be used for binary classification problem. Now, when to use logistic regression? We will understand first the scenario where we are going to use the logistic regression. Logistic regression model is used in a scenario where you have a binary outcome variable which can take value 0 or 1, that is yes or no, where 1 stands for probability of event and 0 stands for probability of non-event. There are a couple of independent variables in your model which is influencing the dependent variable, and there is a presumed relationship between the logarithmic transformation of odds and the dependent variable. Now comes what is a logit function in a logistic regression model. The logit function in a logistic regression model is a natural log transformation of the odds. Now what is odds? Odds is the ratio of probability of success by probability of failure. and odds ratio is basically the ratio of the odds. Now, as in linear regression, we have seen that the line of best fit is a straight line. For a logistic regression, the line of best fit or the curve that best fits the logistic regression model is a sigmoid curve or a S-shaped curve, which shows that the values or the probabilities that we are predicting that cannot fall below 0, neither it can go beyond 1, because probability values ranges from 0 to 1. In a logistic regression model, they use the sigmoid curve to map the logarithmic transformation of odds to the probabilities. Now let's come to the standard form of the logistic regression model, that is how the equation looks like. Probability y equals to 1 is equals to 1 by 1 plus e to the power minus beta naught plus beta 1 x1 plus beta 2 x2 plus dot till beta n xn plus ei. In real time scenario, error terms exists, but in places you will see places the equation they are sometimes given with ei or without ei, but in the real time scenario your ei will exist. Now beta 1, beta 2, these are your coefficients, where beta naught is the intercept coefficients and the rest are the regression coefficients, the slope coefficients. X1, X2, X3, xn are your predictor variables. Now let's discuss about the assumptions of logistic regression. First, the dependent variable should be binary in nature, which can take value 0 or 1. Observations should be independent, that is they should not get influenced by each other, and the logarithmic transformation of your odds should give a linear model. That is, the logarithmic transformation of odds should be linearly related to the set of independent variables of the predictors. Now, what are the steps that we are going to follow to build the model? First, we are going to collect the data, clean and scrub the data as per our requirement. Then we are going to choose the set of relevant independent variables that are going to create impact on our dependent variable. Then we'll fit the logistic regression model using the set of significant variables or the chosen variables, and then we'll be assessing the performance of the model, that is how good is our model fit based on the set of the significant independent variables that are chosen, that is model evaluation. Now what are the values using which we are going to interpret the results? The first are the coefficients, that is beta 1, beta 2, beta 3, the coefficients that we are getting in our model. Indicates how the log of odds change with a 1 unit change in our predictor variable. We'll get a confusion matrix from where we are going to calculate sensitivity, specificity, false positive, false negative, and also accuracy or percentage classified, correct, that is percentage correctly classified in our model. Now what is sensitivity? Sensitivity is correctly classified events by total number of observed events. Specificity is correctly classified non-events by total number of observed non-events. False positive is incorrectly classified events by total number of predicted events, and false negative is incorrectly classified non-events by total number of predicted non-events. Here events is probability y equals to 1 and non-events is probability y equals to 0. The case study that we are going to work with, here my event is probability y equals to 1, which denotes that the employee is going to retain in the company, and probability y equal to 0 denotes the employee will not retain in the company. Accuracy of the model or percentage correctly classified is total number of correctly classified events plus total number of correctly classified non-events divided by the total number of observations. Now the plots that we are going to use, that is the data visualization plot that we are going to use for logistic regression model, is a ROC curve, which stands for receiver operating characteristic curve. We will be plotting the ROC curve and we will be getting the area under the curve, which stands for AUC. If the AUC value, that is the area under the curve value, is closer to 1, then we will see the model is a very good fit. That is, the explained variation of the model is high. So more is the AUC values, that is more it is closer to 1, then better is our model. Now you need to also remember that the maximum value of your AUC, that is area under the curve, is 1. Now let's move to the practical implementation of logistic regression model. I'll be showing you all the practical implementation of logistic regression model on SAS. So first I have created one folder. In order to create a folder, you can go to files, just right click on it, go to new, go to folder and just create a folder. Here I have created a folder named HR Analytics and I have saved it. Now I am creating a library based on the HR Analytics folder using this libnym statement. That is libnym HR, within quotations I have given the path of the HR Analytics folder. So if you right click on HR Analytics, and click on properties, then you will get the location of it. You can copy the location from here and just paste it. Now run the libnym statement. To create the library. So here HR library will be created. So if you open the libraries, you will see HR library is created. Now we will be importing the dataset. Now here first you need to upload the dataset. So I have uploaded the dataset in the HR Analytics folder. So click on the HR Analytics folder, go to the upload option. Now you have to choose the file which you need to upload. Choose the file which you need to upload. So I have uploaded the HR data. Upload. So here HR data, see HR underscore data, this is already uploaded. You can go to properties and take the location of the raw data file or the CSV file which you need to import. So here you will copy the location. So I am doing prop import data file equals to within, I have copied the location of the logistic, the dataset that I will be used for logistic regression model, that is HR data. Out equal to HR underscore log, that is the, after importing the CSV file into SAS, the name of the dataset I am naming it as HR underscore log, that is my SAS dataset. That is after the CSV file is getting converted to a SAS dataset, the name will be HR underscore log, which will be created inside the HR library. Then replace, CSV file is getting replaced by the SAS dataset and then run. Now let's run this code. So see, you have 1470 observations or rows with 15 columns. Now let us view the data and display and descriptive portion of the dataset. Prop print data will give you the data portion of the dataset. So prop print data equal to library name or dataset name I have specified and then run. So this is the data portion of the dataset. This is the data portion of the dataset. Here, this is your attrition which we are measuring, which is a binary variable taking the value 0 or 1. That is your observed value of the dependent variable. Now in order to check the data overview or the data dictionary, I am going to do prop contents data. Or to check the descriptive portion of the dataset, I am doing prop contents data equal to HR underscore log and then run. You see the descriptive portion of the dataset is given the number of observations, the number of variables, dataset page size, file name. The most important is this, the alphabetical list of the variables, whether the variables are format or informat, whether they have labels or not. If labels are there, then labels will be there, whether there is a secondary name to the variable or not. But here there are no secondary names, all the variables only have the primary name. The primary names of the variables, their data type, their length, format, informat, all are displayed. So this is all about your data dictionary. Now we'll be running the logistic regression model. We'll be using proc logistic data, that is the procedure name. Proc logistic data equal to HR underscore log descending. Model attrition equals to, these are the set of my independent variables starting from business travel up to years with current financials. Selection equal to stepwise slack width and run. Now this what we are doing, we are going to build the logistic regression model for y equals to 1, and we are going to do Hausman-Lemche goodness of fit test to check how good is our model fit. Selection equals to stepwise lag fit means we are going to do stepwise selection to choose the set of independent variables or to choose the set of significant independent variables that are going to create actual impact on our dependent variable. Here the dependent variable is attrition and the independent variables are starting from business travel up to years with current manager. Now let's run this code. So see, you got the dataset name, response variable is attrition. There are two categories in the response variable, that is two. It's a binary logic model. Fisher scoring is the optimization technique. 1470 observations are used and read. Total 237 observations are there which are observed. 237 observed values are there where the attrition value is equal to 1, and 1233 observed values are there where attrition value is equal to 0. Now the stepwise selection is done. Residual chi-square test is done to do the stepwise selection. To see which of the variables are included in the model. Individually they are shown that which of the variable are added or removed. If you scroll down, you will be finding the summary of the stepwise selection. Now these are the list of the variables which are taken in the model, or which are included in the model. That is job level, marital status, job involvement, years in current role, years since last promotion, number of companies worked, years with current manager. This is an analysis of maximum likelihood estimates, odds ratio estimates. You have the percentage of concordant pairs, discordant pairs and tight pairs. The percentage of concordant pairs is cases where probability of event is greater than probability of non-event. Percentage of discordant pairs is cases of probability of non-event greater than probability of event. Or you can say percentage of concordance cases where probability of event greater than probability of non-event, that is probability of y equal to 1 greater than probability of y equal to 0. Percentage discordant is cases of probability of y equal to 1 or probability of event less than probability of y equal to 0, that is probability of non-event. And percentage tight is cases where probability of event is equal to probability of non-event. Now this is your Hausman-Lemche goodness of fit test p-value, that is 0.9680. So the hypothesis for Hausman-Lemche goodness of fit test is H0 is the model is a good fit and H1 is the model is not a good fit. Here, since the p-value is greater than your level of significance, which is by default 0.05, null hypothesis will be accepted. That means the model is a good fit. Now we are going to use the set of independent variables that are chosen in the stepwise selection, which creates significant impact on the model here, and we are going to generate a classification table for all probabilities values from 0 to 1, and the gap is 0.01. Here also descending is used, the keyword, to build the model for y equals to 1. So let's run this code. You got the dataset name, the response variable, number of observations read, and it is used. Total number of values where attrition is equal to 1 and total number of values where attrition equals to 0. From the observed point of view, you have the model fit statistics, the hypothesis values, the analysis of, that is the p-values, the analysis of MLE, that is maximum likelihood estimates, odds ratio estimates, percentage of concordant, discordant and tight. And this is your classification table. The classification table is generated from the values 0 to 1, that is the probability range. You know, probability value varies from 0 to 1 with a gap of 0.01. You got the correctly classified event, correctly classified non-event, incorrectly classified event, incorrectly classified non-event, sensitivity, specificity, false positive and false negative. The gap of the probabilities is 0.01 as we have mentioned, and this is your dependent variable attrition, and these are your set of significant independent variables which you got in your stepwise selection. Now we are going to plot our ROC curve of our model. So for that we are Doing proc logistic data equal to library name or dataset name. Descending means you are building the model for y equals to 1. Plots only equals to ROC. This is the keyword to plot the ROC curve. Model, this is my name of my dependent variable, that is attrition, equals to the set of independent variables which is significant for our model, and then run. Now let's see our ROC curve. Now this is the logistic procedure we are using. The dataset name is also given, that is HR underscore log. Now ROC curve is given once you scroll down. Response variable is attrition. The number of response levels is 2. It's a binary logic model. Now, the total frequency for attrition value equals to 1 is 237, and the total frequency for attrition value equals to 0 is 1233. We are building the model for attrition rate equal to 1. The model fits statistics, the p-values, analysis of MLE, odds ratio estimates, then your percentage of concordant pairs, discordant pairs, and tight pairs, all these are given. This is your ROC curve, which is plotted between 1 minus specificity and sensitivity. The area under the curve is given as 0.7346, which is quite a good one. That is, if your area under the curve is greater than 0.5, it is greater than 50%. Here it is near about 73%. It is, your model is a good fit. That is, the explained variation of your model is high. Now, ROC stands for receiver operating characteristic curve, which is measuring the amount of explained variation of your model, or how good is your model fitted. Here, since it is 0.7346, you can say 73.46% of your model is correctly explained, which is quite good. Now we are going to predict the value of our dependent variable, predict the probability value of our dependent variable. So we are doing proc logistic data equal to library name dot dataset name descending, because we are predicting the probability of our dependent variable for y equals to 1, that is for y equal to event. That is, we are predicting, as per our case study, we are predicting the probability of employee retention. That is, what is the probability that the particular employee is going to retain in that company. Model, this is my dependent variable attrition, that is equals to the set of significant independent variables: job level, marital status, job involvement, years in current role, years since last promotion, number of companies worked, years with current manager. These are your set of independent variables. Your output data set is result, and P equal to predicted is the keyword to predict the probabilities of your dependent variable. Output out equal to result, we are creating output data set called result, which will be created inside work because you did not specify any library name. Now in this particular output data set, the probabilities of our dependent variable will be predicted. Now let's run this code. So again, you are getting dataset name, the response variable, number of categories of your response levels, number of observations read, used, total number of observations where attrition is equal to 1, total number of observations where attrition equal to 0, model convergence status, model fit status, testing of the hypothesis, p-values, analysis of MLE, odds ratio estimates, your percentage concordant, discordant, and tight. You can go to the libraries, check your work library where your result dataset is given. So this is your result dataset. Now this is the value of your predicted probability. So this is the column which is showing the predicted probability. So you are predicting the probability of y equals to 1. So this is the predicted probability of employee retention. That is, each and every observation is denoting a particular employee. So these are predicted probabilities of whether the employee is going to retain in the company or not. Now we have got the predicted probabilities. Now we have to convert that into binary form, that is to 0 or 1. So we have set the benchmark of predicted probability as 50% or 0.5. That is, if the predicted probability of y equal to 1, that is if the predicted probability of employee retention is greater than 50%, then that employee is most likely to retain in the company. So the status will be equal to 1, and or else the status will be equals to 0. So we are forming an output dataset, data pred underscore result, set result. Result is the name of our input dataset, pred underscore result is the name of our output dataset. Now we are giving a condition: if predicted is greater than 0.5, that is the predicted probability of employee retention is greater than 50%, then the employee is most likely to stay in the company. So status will be equal to 1, else status will be equal to 0, and then run. You see, the status value is also provided beside the predicted probability values. Now we are going to form a confusion matrix between the observed values of attrition and the predicted value of attrition, that is a status variable, that the converted one, that is we have a predicted probability column which we have converted to a status column, which is a binary outcome variable. So between the observed and predicted one, we are going to form a confusion matrix. So we are using the procedure procfreq data equal to pred underscore result. This times freq procedure is used to generate frequency distribution table. You are plotting the table between these two variables, attrition and status. This is your observed and this is your predicted. You do not own the row percent or column percent, so that's why you have used the keyword no row or no col, and then run. Now let's run the code. So see, 0, 0, total number of correctly classified non-events is 0, means non-events is 1226 observations. Observed as 0 and predicted as 1, there are 7 observations. Observed as 1, predicted as 0 is 224 observations, and observed as 1 and predicted as 1, that is correctly classified, total number of correctly classified events is 13. Total number of observations is 1470. From here you can calculate the accuracy of the model. Now the accuracy of the model will be total number of correctly classified non-events, that is 1226, plus total number of correctly classified events, that is 13. 1226 plus 13 divided by total number of observations, that is 1470 into 100. Then you can calculate the sensitivity, that is total number of correctly classified events by total number of observed events. Specificity, total number of correctly classified non-events by total number of observed non-events. False positive, total number of false positive is total number of incorrectly classified events by total number of predicted events, and false negative is total number of incorrectly classified non-events by total number of predicted non-events. These are your predicted values, these are your observed values. So your accuracy, as I told you, 1226 plus 13 correctly classified events plus correctly classified non-events divided by total number of observations into 100. So 1226, that is 1226 plus 13 divided by 1470 into 100. So that gives you around 84.28%. So your 84.28% is the accuracy of your model, or that 84.28% of your model is correctly explained, which is quite good. So your model is a very good fit. So this is all about your logistic regressions, of how you implement logistic regression on SAS using HR Analytics.